Hello, everybody. My name is Mr. Cantor, and welcome to Modeling with Mr. Cantor. Today, we're going to look at Explore Part E. Now, what I want you to do is to please pause this video, read this slide to yourself, try to get an understanding of what they are requiring of you. Okay, welcome back. Let's read this together. The list of fractions between 0 and 1 with denominators between 1 and 3 look like this. We have 0 out of 1, 1 out of 1, 1 out of 2, 1 out of 3, and 2 out of 3. We can put them in order like this: 0 out of 1, 1 out of 3, 1 out of 2, 2 out of 3, and 1 out of 1. Now, what is this symbol here? Have you seen this before? Please pause the video and let me know, what are these symbols? Okay, welcome back. If you said this symbol is called inequality and it's used for comparing values between different numbers, then you are correct. This specific inequality symbol is called the less than symbol, where whatever's on the left is considered smaller than whatever's on the right. So this specific order of fractions is organized from least to greatest, where 0 out of 1 is the smallest fraction and 1 out of 1 is the greatest fraction. Now it says, now let's expand the list to include fractions with denominators of 4. We won't include 2/4 because 1/2 is already on the list. So 2/4 and 1/2 are considered equivalent fractions, and we're going to talk a lot more about that in a second. Now, they're going to put fractions that have a denominator of 4 in this list. And the question is, how do they know how to organize fractions from least to greatest when all the denominators are different? The numerators are different, the denominators are different. How are we supposed to know this? Well, before we talk about how you're supposed to know this, we have to actually understand what a fraction is first. A fraction has two parts to it. It has a numerator and it has a denominator. Now, what a fraction is a comparison of you taking a whole, cutting it into equal sections, and then you are telling us how much of those sections you have. For example, if we take the fraction 1/4, 1/4 is telling us you have a fraction cut into 4 equal sections, and you have one of those equal sections. If you have a fraction like 2/3, then that's saying you're taking a whole, you're cutting it into 3 equal sections, and you have 2 of them. All right, that's what the numerator tells you, 2 of them. 2 pieces out of 3 equally cut slices. So with that said, let's jump into figuring out, how do you organize fractions from least to greatest, given that they have different denominators. So what I've created for you is a slide that looks very similar to the previous one. I just modified it so that we have a little bit more space to work. Now we have this list: 0 over 1, 1 out of 3, 1 out of 2, 2 out of 3, and 1 out of 1. Why are these fractions organized like this? How can we tell? Well, what would happen if we actually made them have the same exact denominators? That's going to really help us understand which fraction is the smallest and which fraction is the largest. Now, in order for us to do that, we need to address a couple things. The first thing we need to talk about is the difference between LCM and LCD. Now, LCM stands for least common multiple, and LCD stands for least common denominator. Now, I know throughout your mathematical journey, you might have seen that these terms are interchanged because they are very, very similar. All right. So what we're going to do is we're going to use the idea of LCM to help us find the least common denominator. So what we need to do is find the least common denominator for these numbers, 1, 2, and 3. So go ahead, please pause this video and try to find what is the LCM or the LCD for 1, 2, and 3. All right, welcome back. Let's work through it and let's see if we got the same answer as you. For the multiples of 1, you're going to notice you have the 1 times table. For the multiples of 2, you're going to notice you have the 2 times table. For the multiples of 3, you'll notice you have the 3 times table. Now we need to figure out that out of all 3 of these times tables, which number is the smallest they all have in common. I said times tables because when you hear multiples, it sounds like multiply, and multiply is exactly in the multiplication tables. So you'll notice that 6 is the LCM. And hopefully that's what you got when you found the LCM of 1, 2, and 3. You will notice that that is the case because 1 is not in 2 and 3. The multiple of 2 is only in the 2 times table as well. It's not in the 3 times table. The multiple of 3, which is in the 1 times table, is only in the 3 times table and it's not in the 2 times table. So in this case, the number that is the same throughout is the number 6. So if you got 6 to be your LCM, good job. So now what we're going to do is we're going to apply the LCM and convert our given fractions to their equivalent form such that the denominator now is 6. Let's look at our first example. We have 0 out of 1, and we're going to convert it to a fraction where your denominator is 6. But how are you going to do that? Please pause this video and let us know what you think you should do next. Okay, welcome back. If you said that you have to take 1 and multiply it by 6 to get 6, then you are correct. Just remember, what you do to the denominator, you must also do to the numerator. That way you maintain equivalence. 0 times 6 is 0, and 1 times 6 is 6. Good job. So 0 out of 6 is equivalent to 0 out of 1. Let's move to the next fraction, 1/2. How are we going to make this 2 become 6? How can we do that? Please pause this video and let me know. Okay, welcome back. If you said we need to take our 2 and multiply it by 3, you are correct. Now, remember, what you do to the denominator, you must also do to the numerator. So if you're multiplying the denominator by 3, you must also multiply the numerator by 3 as well. 1 times 3 is 3, and 2 times 3 is 6. Good job. So now we have an equivalent fraction for 1/2. It happens to be 3 out of 6. Good work. Let's move on to our next fraction, 1 out of 1. We saw in the previous example that 1 times 6 is 6, so we can apply that here as well. 1 times 6 is 6, and we have to do 1 times 6 in the numerator as well, and that's why we have 6 again. So for this fraction, 1 out of 1, its equivalent form is actually 6 out of 6. Good job with that one. Let's keep moving. The fraction 1/3. How does 3 become 6? Please pause this video and let me know, what should we do to make 3 become 6? All right, welcome back. If you said 3 has to be multiplied by 2 to get us to 6, you are correct. Just don't forget, if we're multiplying our denominator, which is 3, by 2 to get 6, then we also need to multiply our numerator, which is 1, by 2 to get to our new numerator. In this case, it is 2. So 1/3 is actually equal to 2 out of 6, and those two fractions are equivalent. Let's keep moving. Now we have 2/3, and we have to find its equivalent form. The good news is we just did a fraction where the denominator was also 3. So what we're going to do is multiply both 2 and 3 by 2, and we're going to get a brand new fraction, and this fraction is 4/6. So 2/3 is actually equal to 4/6. Good job. So now what we can do is we can organize all these fractions directly below the fractions that were given to us, so you can see the connection between how their list is organized from least to greatest compared to our new list, which is organized from least to greatest. You will notice that all the fractions that we have here now are cut into 6 equal pieces. If they're all cut into 6 equal pieces, you will see that having no pieces out of 6 is the smallest, and having 6 pieces out of 6 is the largest in this situation. You will notice then that 0 out of 6 is followed by 2 out of 6, which is followed by 3 pieces out of 6, which is followed by 4 pieces out of 6, and finally is followed by 6 pieces out of 6. So hopefully you were able to see when you're given a list of fractions that are organized from least to greatest, and you're confused as to why they are organized in that specific way, hopefully now you are equipped with the tools to take all the fractions given to you, change them to have the same exact denominator, so now you can compare and figure out which fraction is least and which fraction is greatest. Thank you so much for watching this video. My name is Mr. Cantor, and I will see you in the next one. Take care for now.